Hello friends, welcome to Suresh Agarwal's Mathematics Shortcuts. Yet another video on the very important topic of basic proportionality theorem. Now these are some of the long questions, 3 marks or even 5 mark questions which are based on this important theorem, the basic proportionality theorem, in the important chapter of triangles and especially important for class 10th board exams. So before I get into the questions, let me tell you about the CBSE practice worksheets which we have recently brought out, and very nominal costing, unlimited validity stuff. And if you want to practice concept wise, that means one concept at a time, all the questions at one place, and it will enable better understanding of the concepts, then you can go for this. These are available for class 6, 7, 8, 9 and 10, all classes, and some of the classes we have the videos also. So if you want to get a copy of this, you can send me a message on WhatsApp 9896369963. That is the WhatsApp number. You will find this number in the description also below. Okay, let's see the first question now based on the BPT, the basic proportionality theorem. So you can see here there is a figure where x is the midpoint of this side BC. So these two are equal, and we have joined AX, and y is the midpoint of AX. So we have labeled it here, AY and YX are equal. So we need to prove that AZ is 1/3 of CA. So this part AZ is 1/3 of CA. So we'll be able to prove this if we prove that all the three parts here, AZ, ZS and SC, all these three are equal. So if these three are equal, then one of the parts will automatically be 1/3 of the total line, that is AC, right? So that's what I am intending to do in this question now. For that, this is to be proven, right? So I'll do a construction. What is the construction? You can see a dotted line here. This dotted line is drawn parallel to this line BZ. So draw XS parallel to BZ. Very important, because if we don't have a parallel line, then we cannot apply basic proportionality theorem. So to apply basic proportionality theorem, we need to have a parallel line, and that is why we have constructed it. And now let us take triangles one by one. So the first triangle I am taking is in triangle AXS. So you can keep on watching the figure. YZ is parallel to XS, because we have made the construction that these two lines are parallel, and so we can apply BPT. So by BPT, AY upon YZ, YX, AY upon YX is equal to AZ upon ZS, AZ upon ZS. Now in this part you can see that these two parts AY and YX are equal because Y is the midpoint. So AY and YX are equal. That means this ratio will be 1, AZ upon ZS. We will give the reason as AY is equal to YX, right? So if you cross multiply this, you will get AZ is equal to ZS. Now this is equation number 1. I managed to prove that AZ and ZS are equal. Likewise, I will change the triangle now. CBZ. In triangle CBZ, can you name the parallel lines? We have XS and BZ. XS parallel to BZ, and therefore by BPT again I can use the ratios. So let's start with the ratios from C. CX XB, CX and XB, the ratio is equal to CS and SZ. CS and SZ. Now again you can see X is the midpoint, so CX and XB are equal. So this ratio will become 1. That means 1 is equal to CS upon SZ. Give the reason as CX is equal to XB. And so if you cross multiply this, you are going to get CS is equal to SZ, which forms the second equation. So now see the first one and the second one. AZ and ZS are equal, CS and ZS are equal. That means from 1 and 2, all these three parts are equal. You need to write that, and therefore we can say that one of the parts AZ will be 1/3 of the complete line, that is CA, and that completes our proof for the question. So you can see how the BPT helps us in getting to the proof of such questions. Let's see this one now. So there is a quadrilateral here. You can see A, B, C, D is a quadrilateral, and we have joined the midpoints of the adjacent sides. So the midpoint of AB is this P, the midpoint of BC is Q, so we have joined PQ. Likewise, R is the midpoint of CD, we have joined QR, and S is the midpoint of DA, we have joined RS. Now we need to prove that this figure which is formed PQRS, it is a parallelogram. So what is the basic property of a parallelogram? The pair of opposite sides, they are parallel. If we can prove that PQ and SR are parallel and PS and RQ are parallel, then it forms a parallelogram. Both pairs of opposite sides have to be parallel, and that's what I am trying to do now. See, here in this side, AS and DS are equal, correct? Because S is the midpoint. That means the ratio of DS and AS is 1. When two things are equal, their ratio is always 1. Likewise, if you see here, DR and RC are equal, and that means the ratio of DR and RC is also 1. And from these two, since both the ratios are 1, we can write DS upon AS is equal to DR upon RC. See, DS upon AS equal to DR upon RC. Now can we use the basic proportionality theorem? So using this, by converse of BPT, when the two ratios are equal, then this line SR is parallel to this line AC, right? So we managed to prove that SR is parallel to AC. What will happen if I start not from this triangle DAC, I will start from BAC. In that case, BP upon PA and BQ upon QC will be 1, both 1. So QP is parallel to AC. We can write that as similarly. Similarly, PQ is parallel to AC. And since two lines SR and PQ both are parallel to the same line, therefore they are parallel to each other. And so what did we prove? SR is parallel to PQ. See, that's what I wanted. The opposite sides of this figure should be parallel, right? Likewise, had I joined diagonal BD and taken the triangles CDB and ADB, I would have proved that PS is parallel to QR. Now I will leave that second part for you, and I am writing similarly, but in the exam you need to prove that part also. Similarly, PS is parallel to QR. You have to obtain that also, and then you have to write, therefore opposite sides of quadrilateral PQRS are parallel. That means the quadrilateral PQRS is a parallelogram, and that completes our proof. See, I have left one part here as a DIY, do it yourself, because it is similarly, exactly the same as the first part which I have solved here. So you need to complete the proof, okay? Let's see this question now. If three or more parallel lines, so there are three lines here, L, M, N, they are all parallel lines, and there are two transversals, this AB and CD, intersecting the lines at P, Q, R and E, F, G, right? So we need to prove that the intercepts made by them on the transversal are proportional. What are intercepts? If this is the transversal, what is the portion of the transversal between the two parallel lines? It is PQ, that is called intercept. here it is QR. So the ratio of PQ and QR, the two intercepts, so what is to be proven here? Let's write to prove. The ratio of these two intercepts PQ and QR is equal to the ratio of intercepts on the other transversal EF and FG. Now we need to prove this. And how do we prove this now? Again using basic proportionality theorem. So in the construction, what did I do in the construction? I have joined this line PG. Join PG, that's G, PG intersecting QF at M. QF at M. And now we can safely use the basic proportionality theorem because there are parallel lines. So first triangle I am going to use is PRG. In triangle PRG, can you see parallel lines? QM and RG are parallel. So by BPT we will have one result, PQ upon QR is equal to PM upon MG. So we will call this as equation number 1. Likewise, let's change the triangle now. In triangle PEG. So which are the parallel lines? MF is parallel to PE. MS is parallel to PE. And therefore by BPT again, I will have one more result. PM upon MG is equal to EF upon FG. And this becomes the second equation. Now if you see the first and second equation, PM upon MG is the common term here, and therefore the other two sides will be equal. So PQ upon QR, that's what I wanted to prove, right? PQ upon QR is equal to EF upon FG. Now that completes our proof for the question. So all understanding based questions, if you understand the theorem, the converse, and you are skillful enough to apply those concepts in these questions, the questions are not going to be difficult. So solve all the questions which are given in the corresponding practice worksheet, and I am sure this is going to help you in cracking any question in the board exam. So do share this video with your friends. Do not forget to subscribe the channel and click the bell shaped icon for getting all the notifications on the channel. Thanks for watching this, and look for more amazing parts of this series of videos on triangles. All the best.